Hello everybody and welcome to another FHM Network Academy training video. I'm Sasan Farahmand and I'm so honored and grateful to be with you again. In this video, we will talk about bus topology, which we talked about in network topology training video. But in this video, we will talk about bus topology in detail. A bus network is a network topology in which nodes are directly connected to a common half-duplex link which is called bus. Since media in bus topology is shared, every node will receive all network traffic, and the traffic generated by each node has equal transmission priority. In bus topology, all the computers are connected through a single cable. Usually, Ethernet cable is used for bus topology. In this topology, the information intended for the last node has to pass through all the computers present in the network. If this cable, the backbone cable, is damaged, then the connection of all the computers will be lost. We can use coaxial and twisted pair cables in bus topology. Depends on the type of computers used in the network. In bus topology, data is transmitted only in one direction. Access method or principle or rules that every single node should follow to access the media and send signal and information is called CSMA-CD. CSMA-CD is a stand for Carrier Sense, Multiple Access, and Collision Detection. To understand the access method of bus topology, we need to consider the characteristics of this topology. As you know, the physical topology and logical topology in bus are equal. Bus topology is a kind of topology that physical layout and the logical procedure to access the media are equal. When you take a look at the image and the physical layout of this network, it is easy to understand why we need this access method. As you know, we have a shared bus, and whatever, for example, node 1 sent to the media, all other nodes would receive. So each node, before sending any signal to the media, should examine the media to ensure if it is clean or not. Because of being shared, just one node could send signal into the media. So before sending signal to the media, nodes must listen to media and ensure the media is clean. Again, because the media is shared and all nodes in the network receive signals, every node should have a unique address to understand if they are the destination of a frame that's sent through the network. So let's talk about the first part of the access method, or carrier sense, in detail. The first condition for nodes to access to the media is the fact that media must be clean. So every node should listen to media, and if the media is clean, they could send their messages to the media. And all of this come from these characteristics of bus topology that the media is shared. As you know, all nodes in the network should have network interface card in order to connect to the media. Every network interface card has two channels, one for transmit signals and one pair for receive signal. All nodes in the network listen to media with its receive pair, and if there is no signal in receive pair of their network interface card, it means the media is clean. So it is important to all nodes to ensure that the media is clean before sending any signal. So this is where the network interface card receive pairs comes into action and receive all signals from media. As it receives signals from the media, the node realizes that the backbone or network is clean or not. So if any node receives signals from receive pairs of its NIC, it means the node should wait to the time that the media to be clean. So to sum up, to meet the first condition of Bus topology, which is the media must be clean, every single node should listen to media, and if the media is not clean and there is signal on the media, the node should wait to media to be clean. The second condition to access to the media in this topology, since the bus topology is multiple access, is the fact that data must have a frame. As you know, when the data is going to send from sender to receiver, data comes from data link layer, which is the second layer of the OSI reference model. And when data comes down from data link layer, it should be packed into a frame, which should be labeled with address of source and destination. And after creating frame, the frame comes down to the physical layer, the layer that actually turns frame or bits into signal and send them through the media. The necessity of having frame in bus network is the fact that since the bus network is a shared bus or a shared network, all computers or all nodes through a network would receive all signals and frames. So if we don't have address in our data, we couldn't understand who is the sender and who is the receiver. When a request sent to a network to a specific destination, no one knows how to answer these requests and where to send the response because there is no address over there. It is necessary to tag the information with the address of source and destination. On top of that, we need to frame our information and specify the first bit and the last bit that's sent to the media. Having frame is necessary to understand where a frame or a chunk of data start and when or where this frame finished. So the second condition for accessing to media is the fact that sender should have a frame to specify the first and the end of a chunk of data. The third condition for accessing to media, as I mentioned earlier, is the fact that each node must have a unique address. In network components training video, we talked about physical address and its characteristics. And you know that we have a hexadecimal address which is written on the network interface card, and it must be unique all around the world. So the first part of this address, which is called organization unit identifier, and the second part is the address or a random address which is assigned by vendor. So as you can see on the picture, right now we have address, and each node besides their name, they have physical address which is known as a MAC address. And when, for example, node 1 send information to node 3, node 1 must create a frame and tag the frame with the source and destination address, and these address must be the source and destination MAC address. For example, in this frame we have source MAC address, which is the MAC address of the node 1. And in the destination part, or in the destination field, we have the address of node 2. So when this frame turns into a signal and sent through this media, all these nodes, I mean node 1, 2, 3, 4, and 5, would receive this signal and turn the signal into frame. And all of them read the destination address part of the frame. And the node that finds its MAC address on the destination field would answer or respond the request to the source, and all other nodes would drop the signal or frame. So this is why we need frame for our information, and again we need address to tag the frame, and also the address must be unique, which is organized by these two parts, I mean OUI and vendor assigned part of the MAC address. Another conditions for access to the media is the fact that we have a shared media. If two nodes send their information or send their signals at the same time, the signal would collide to each other. So each node must listen to media before transmission. And when the node realizes that the media is clean and starts sending signal, the node should compare the signal that being sent to the media with the signal that being received from the media. They have a part in their network interface card which is called loopback and held NIC to compare the signal that is sent to the signal that is received. So if the signal that is sent is equal to the signal that is received, it means the node that is sending signal to the media is the only node that is sending and no collision happens. What if the signal that is received is not equal to the signal that is sent? It means some other guy or other node sent signal at the same time. So the signal collide and collision happen. And this is why the signal that is sent is not equal to the signal that is received. So if the signal that is sent is equal to the signal that is received, so everything is okay and the sender could continue sending signal. But if the signal that is received is not equal to the signal that is sent, it means a collision happen. So to fix this problem, all those nodes that detect the collision should stop transmission and send jamming signal to inform other nodes about collision. After sending jamming signal, they have to wait for a random amount of time before start sending again and start from the first step, which was listening to the media. Let's take a look at the procedure of the CSMA CD or Bus Topology access method again. In the first place, the node that want to send information should assemble a frame, and after assembling the frame, the node should listen to media and realize that the media is clean or not. So in the second place, the question is some other station transmitting? This procedure is what I told you that happened in loopback part of the network interface card. So all nodes from their receive pairs receive signals that has been sent through the media. So if there is any signal on the media, they have to wait for a random second and again listen to media. And if the media is clean, the answer of this question is no. The media is clean. So the node start transmitting the first bit of the frame and again compare the signal that is sent to the signal that is being received. So if they're equal, everything is alright. What if they're not equal? It means the collision happened. So if the collision happened, they stop transmission and wait for random time. And after that, the procedure goes back to the first step and listen to media and answer the question, is some other station transmitting? And if not, the rest of bits of the frame will be sent. And why those bits are transmitting over the network, the process of comparing sending signal and receiving signal would continue. And if nothing happened and no collision detected while sending those bits, it means transmission would be successful. Let's talk about advantages and disadvantages of bus topology. The first advantage of bus topology is the low cost cable. In bus topology, nodes are directly connected to the cable without passing through a hub or any intermediate devices. Therefore, the initial cost of installation is low. Since we can use coaxial cable in bus topology, we could have moderate data speed up to 10 megabit per second in bus topology. Bus topology is a familiar technology as the installation and troubleshooting techniques are well known and hardware components are easily available. A failure in one node will not have any effect on other nodes, which could be considered as another advantage of the bus topology. Let's talk about disadvantages of bus topology. Extensive cabling could be considered as the first disadvantage of the bus topology. As I mentioned, a bus topology is quite simpler than any other topology, but still it requires a lot of cabling. Bus topology requires specialized test equipment to determine the cable faults. If any faults occurs in the cable, then it would disrupt the communication for all the nodes. So troubleshooting could be difficult. As you know, if two nodes send the message simultaneously, then the signal of both nodes collide with each other and collision would happen. And this drawback can be named as a signal interference is another disadvantage of bus topology. Adding new device to the network would slow down or cause downtime in the network, so reconfiguration could be difficult. Attenuation is the loss of signal leads to communication issues, which could be fixed by repeaters. And in the bus topology, since we send signal through a media, we could have distortion and attenuation through a network, and it must be fixed by installing repeater at the end of each media segment. So this is all you need to know about bus topology. And the last one that you need to know is the fact that bus topology is not available anymore. But the access method, or CSMA CD, is the access method that is used in a star topology. So you need to understand bus topology and CSMA CD access method to understand the star topology and what is going on in nowadays Ethernet network. This was all you need to know about bus topology. And this is the end of this video. Don't forget to like, share and subscribe. I hope you will find this informative and useful, and I would like to thank you for watching.